You're listening to Skeptoid. I'm Brian Dunning from Skeptoid.com. Are we alone? Radio telescopes scan the skies, and computers crunch the results looking for the patterns that might indicate an artificial signal coming from deep space. Alien hunters stand watch out in the desert looking for lights in the sky flying over military bases. Both are looking for answers to the same question. Is our little civilization on our little blue planet alone in the galaxy? Or are there others like us who want to meet us as much as we want to meet them?
Are there technological alien civilizations out there?
Most astrobiologists think so. The physicist Enrico Fermi, upon comparing the apparent lack of any evidence of visitation to the inevitably huge number of civilizations out there, once famously blurted out, "Where is everybody?" The most famous attempt to answer this question is the Drake equation, when Frank Drake strung together 7 relevant variables in 1961. Multiply them all together, the fraction of the stars that have planets, the fraction of planets that develop intelligent life, the fraction of those who choose to send signals into space, and so on, and you'll get the probable number of technological civilizations out there that we might hope to meet. The obvious problem is that our estimates on most of these variables are all over the map. At Frank Drake's SETI Institute, the Search for Extraterrestrial Intelligence, 130 scientists in every discipline imaginable pursue research in more fields than you could shake a stick at, all of which helps to refine our estimates on each variable. The best guesses these days run from around 1 to 10. But nobody at SETI pretends that we have a good handle on this. Frank Drake himself said the equation was useful only for organizing our ignorance on the question.
Do the aliens exist at the same time as us?
A factor that many people fail to consider is time. Think of the galaxy as a Christmas tree with blinking lights throughout its space. Each brief light pulse is the life of a technological civilization. While there may be many lights turned on at any one given instant, the chances of 2 adjacent lights being on at the same time is much lower. Even if we could look into the night sky and see a big bright indicator light for every world that has a civilization, remember that that information is hundreds, thousands, even tens of thousands of years old. If we launched a spaceship to any one of them, even if it could travel at some meaningful fraction of light speed, the chances of that civilization still existing by the time we got there are small. Even civilizations that survive their nuclear age and manage not to kill themselves are still vulnerable to Mother Nature. Terrestrial killers like supervolcanoes and pandemics, and cosmic killers like asteroids, novas and supernovas, can all destroy the hardiest populations. No civilization lives forever, and on a 14 billion year timescale, very few will happen to live side by side at the same time.
Could aliens get here?
The problems of interplanetary travel are well known. The distances, time, and energy requirements are all well beyond our current technology. These problems are equally difficult for the aliens. Even if we grant that their physiology may be well suited to multiple century hibernation, the fact remains that interstellar space is a resource-starved desert, and all the energy needed to decelerate must be brought with them. We should also consider whether the visitation mission was one-way or round-trip. Our Pioneer and Voyager probes are certainly only one-way. Building a vehicle intended to visit another star system and then return would be orders of magnitude more difficult. If it were intended to land, it would need to provide for re-entry for not just the lander itself, but also for an entire launch vehicle capable of taking off, breaking orbit, and returning. A far more plausible plan for a round-trip vehicle would be orbital only, as this would greatly reduce the energy requirements for the return, but it also limits the science that can be done, and would not allow for direct contact. Exotic science fiction solutions that avoid the problems of travel, like wormholes and space folds, have been studied, and we do have a journeyman's understanding of them. Traversable wormholes, shortcuts from one point in space to another, have been theorized, but would require the use of exotic matter that has only been hypothesized. Folding or distorting space around you, called a warp drive in Star Trek terms, also has interesting real-life hypotheses, But the problems include absurdly immense energy requirements, even to transport just a few atoms, and the self-defeating restriction that creating a warp bubble to travel 100 light-years must always be preceded by preparations taking at least 100 years. Of course, just because we haven't solved these problems doesn't mean no civilization can solve them. But while this special pleading is a philosophical possibility, it's not a practical possibility, according to what we've learned so far. This applies equally to the supposition that a civilization might have colonized its neighboring star systems, thus escaping cataclysm, and surviving and propagating indefinitely. But the problems of interstellar travel and the relative scarcity of suitable planets make colonization just as unlikely as visitation.
Would aliens come in person, or would they send a robot ship?
Sending a robot ship is much more practical. It can deliver all the messages, greetings, and information that the living aliens could. It has no need to carry life support systems, and its much smaller size makes the energy requirements far more achievable. Even if the aliens planned to travel in person, they'd probably do as we've done with Mars, Venus, the Moon, and all the other heavenly bodies we've visited. Send robotic probes first. No lives are risked, and a better understanding of the environment can be learned before sending living beings.
What would the aliens do here?
The question of what aliens would do if they got here is pretty hard to answer. There's no way we can know, but we can guess based on what we'd probably do if we visited someone else. When we sent out the Pioneer and Voyager probes, we put as much information about ourselves as we could on board. What we look like, where we are, and a golden record with some recordings of sounds on Earth. Our best guess is that visiting aliens would want us to know about them and help us to reply. A fringe belief here on Earth is that aliens have visited, but merely stacked some rocks into pyramids or drew a pattern into a cornfield, then left. It seems unlikely that if we were to go to all the massive development and cost of deploying a probe to an alien civilization, that this would be the plan we'd choose. We'd want to know about them, and we'd want them to know about us. The mission most likely to be successful would be to simply land as much information about ourselves as possible. Visiting aliens would probably do the same thing. Simply land information about themselves. No return, minimal risk of failure. We would probably not expect to have the energy available for our probe to fly around, move rocks, or evade their version of fighter jets. Maybe later in our technological development we might, but our first attempts at contact were simply to send a golden record.
Would we know whether they'd been here?
This question is largely answered by whether the aliens' visit was one-way or round trip. Let's say we detected an alien civilization, then decided to send a space probe. By the time the probe got there, a huge amount of time would have passed, and it's entirely likely that during that time, the alien civilization would have advanced enough to make our visiting probe obsolete. So it might be a pretty good gamble to not bother intending the probe to make a round trip, but rather to allow the alien civilization to respond with whatever newer technology they'd developed in the interim. Considering the cost, energy cost or financial cost, we could probably land dozens of one-way probes for what it would cost to develop and launch a single round-trip probe. These costs would be the same for the aliens as well. Given the technological difficulties and greater energy requirements of a round-trip probe, coupled with the probability that a one-way lander would be the better way to do science and invite a response, it's probable that we would know the aliens had visited us. Chances are we would have their probe on display in the Smithsonian and would have followed the instructions on their golden record to reply. We've never discovered an alien golden record, or a one-way alien probe, or any other evidence that we've been visited. So it appears that no aliens have yet visited us with the easiest, most probable option, a one-way, unmanned robotic probe.
Could aliens skirt the problems of physical travel by visiting in some other non-physical form?
Some like to suggest that advanced aliens might astrally project themselves or find some exotic, non-corporeal way to visit. This might make interesting fiction, but it bears little resemblance to what we've learned about the way the universe works. In reality, there is a way to non-corporeally accomplish the most probable mission, to deliver information about your civilization to a neighbor. Don't spend trillions of dollars and hundreds of years to land a box of stuff. Beam the information there, now, at light speed, for minimal cost, via radio. Anyone intelligent enough to listen for signals has already thought about translation. There are universal and mathematical constants that can be used as reference points. The Fibonacci series, the value phi, atomic mass units, Avogadro's number, and so on. All of which brings us back to our original answer. The least likely scenario is that we'll be visited in the flesh, and there's no evidence that's happened. What's more likely is that we'll be visited by a robotic probe, and there's no evidence that's ever happened either. The most likely scenario is that we'll hear from our interstellar neighbors on the radio, and for as long as we've been listening, we haven't heard that yet either. And so, are we alone? I don't think so. We know these problems are really hard to solve. If any pair of civilizations out there has solved them, we weren't included in the party. That doesn't mean we won't be tomorrow, or next year, or in 100 years. Keep an eye on the sky if you must, but if we're going to meet our neighbors, chances are it will be the radio telescopes that find them first. For more Skeptoid weekly in your inbox, sign up for the email newsletter and get my Wacko of the Week and other regular features. Come to Skeptoid.com and click on Newsletter. You're listening to Skeptoid,
a listener-supported program.
I'm Brian Dunning from Skeptoid.com.